Okay, question 6. I've helpfully just put in what's at the front of your sheet as well. When you see these questions, when you see a cos 2x or a sin 2x, you should be thinking to yourself, I am going to have to use my identity. So I'm just going to, when you see this, you should be thinking, okay, I'm going to have to use one of my identities. Now, what you want to do is have everything in terms of sine or everything in terms of cos, yeah? So if I've got a cos 2x, I want rid of the cos 2x and I want to put sine in, so I've got all sines. If that was a cos and a sine, vice versa, okay? So we want to get rid of this, and we want to make sure we put a sine squared in. So if I put this in, it's just as complicated. Put this in, really complicated. It's this one you want to put in. So step 1, we're going to say 5, over here. So 5 sine x, take away 4, is equal to 2 multiplied by my cos 2x. Can use this. So that's 1 take away 2 sine squared x. And just don't forget your bracket there as well. And then we'll start to multiply out. So 5 sine x, take away 4, so that's 2, take away 4 sine squared x. And we'll get everything over to one side, so I'm going to end up with 4 sine squared x plus 5 sine x. And if I take away 2, I'll end up with take away 6 equals 0. So that might look familiar to you. That is really just a trinomial, power 2, power 1 unit. And instead of saying sine x, I'm just going to put a note here to say that sine x is equal to big X. That just makes my life a wee bit easier for the writing. Okay, so 4x squared plus 5x, take away 6, is equal to 0. And I'm looking for numbers that add to this and multiply to negative 24. So, if it doesn't jump out at you, just write your factors down. Okay, so 1 and 24 would work. 2 and 12. 3 and 8. There we go, 3 and 8, isn't it? Yeah, fantastic. So for that, 4x squared. Again, this is the trickier type of factorising. If you can do this, very good. I'm saying it's going to have to be then a plus 8x take away 3x. Yeah, fantastic. So they multiply to negative 24 and they add to give me 5. Very good. So draw a little line down the middle and take out your common factor. It's going to be x plus 2. Copy your equation, your bracket, and then say, what do I need to put in front of this to give me this? Well, that looks like negative 3. So then you've got 4x, take away 3, and x plus 2. And we're nearly finished. I'm just going to move up to the top here. If my little rubber's upset. There we go. So let's move up to here, where I'm going to say that means 4 cos x take away 3 and cos x, sorry, it was sin x, wasn't it? Sorry, sin x, not cos x. 4 sin x take away 3 and sin x plus 2 equals 0, and don't forget your equals 0 here as well. So I've just now replaced my x with the sin x term. And what that means is my final solutions, final answers, are sin x is negative 2 and sin x is 3 over 4. And right away you can say, well, look, this doesn't work. Sin x never equals negative 2, because I have to draw out my sine graph. Well, my sine graph does something like this. It goes up to 1, down to negative 1. Negative 2 would be down here somewhere. So no, that doesn't work. So you can say that's an invalid solution. That's fine. Pardon me. But what you have to do is go and solve the last bit, which is sin x is 3/4. So I'm going to say, right, I'll try and do it below here actually, just so it looks a bit neater. So x is equal to sine to the negative 1 of 3 over 4. So we'll get our calculators out. Just give me 2 seconds. Okay, so that's going to be 0.848 radians. Say rad there. So don't forget, put your calculator in radians mode. Make your life nice and easy. You don't need to convert or anything. Just stick your calculator in radians and that's fine. And the last thing we need to do here is to say, well, what are my other solutions as well? Because don't forget, we've got our sine graph. You know, if x is 3/4 is, say 3/4 is there, you know, if that's 1, there's 3/4. We're looking for a solution here and a solution over here as well. So that's your cast diagram. Yeah. I am sine is positive, sine x is positive 3/4. So it's going to be in here and in here. So a quadrant 2 answer, okay, quadrant 2, so a quadrant, let's start with quadrant 1 answer first. So quadrant 1, it was just x, so it's just x equals 0.848, that's fine. Quadrant 2, now we're used to this in degrees with 180 takeaway, but this is where you'll have to think about your radians. So how many radians are there in 360? 360 degrees is 2 pi radians. So 180 degrees is pi radians. So this one in here, it would be 2 pi take away x. This would be pi plus x, and this would be pi take away x. Don't forget that. Okay, so pi, so it'll be pi plus my x, and that's going to give me 2.293 radians. That's right, radians as well. Okay, so actually the only bit that maybe you might have thought, wait a minute, I've not done that for a while, is doing your second quadrant with your radians. So let's just go for our answer, go for a marking scheme, see what we got. So you're getting a mark for the substitution at the beginning, so that's an excellent mark to get. The rearrange, your next mark was over here, and you're getting a mark for the 3/4 and the -2, so a mark along here, so this line to solve, and then a mark for your final 2 answers as well. So yeah, not bad at the beginning, really. 2 marks for just substitution and rearranging, very good. But yeah, nice little question. It's maybe just to get you going is maybe the tricky bit, because certainly from here on, that's well covered in the course. This bit, maybe you didn't realise that, but okay, so that's covered now. And this, just to get you started, factorising from National 5 and a little bit of substitution. If you follow through the steps, it's very logical. It's almost like a three-parter. You're getting the trinomial, you're solving the trinomial, and then you're kind of in trig solving. So yeah, I hope that's helpful, and nice little 5 marks.